Hello, welcome back to the continuing lecture in investments. So, in this session, we will actually find the value at risk based on our table 5.1 example. Remember the table 5.1, right? This was the right. Scenario analysis, right? And 4 scenarios, right? Severe recession, mild recession, normal growth, and economic boom. And with, each probabilities of 5%, 25%, 4%, and 3%. I mean, 30%, right? 40% and 30%. And in this scenario, the expected return on the portfolio was 10%, right? Expected portfolio return, right? And the standard deviation was 18.63. So based on this data, right? And let's find out, what is the value at risk in the worst case scenario of the severe recession, which has 5% probability. And it's not only that, we're going to also look into other the cases of probabilities, but so basically, what we need to do is what would be the loss in the worst 5 percentile case, the bottom 5%, right? That's 5 percentile, bottom 5% is, and bottom 10% or 10 percentile case, 15 percentile case, we can, and suppose we have, $1 million under our management, right? That's the fund size that we are managing. And we already know our mean is, we can, directly link to that. So equal sign, and I'll click that and also lock it, right? That way, and our standard deviation is also this one, and we're going to lock it because that way we can, just, copy and paste it all the way down without worrying about the cell referencing to the wrong cell. So first, now the worst 5. What would be the z value, right? What would be the equivalent z value for bottom 5%? Remember, in our in the last class, right? Let me quickly switch to what was the scenario last time? You should be able to see it. I should be able to see it just about. Should be coming up. Yeah, there you go. So this was the idea. In other words, what would be? I mean, this is already, 2 standard deviation below mean is the bottom 2% or 2 percentile, right? It's open-ended. And if it is, bottom 5% or 5 percentile, right? Z value, Z score of the bottom 2% is 2 standard deviation, right? Then what would be the what would be this cutoff line, right? What would be this threshold for bottom five z-score, or the position in terms of standard deviation, right? What would be the position of 5 percentile, right? In terms of standard deviation, and my rough approximation or rough guess was it would be about, wouldn't it be about 1.67, 1.65? I mean, 2%, below 2% is, 2 standard deviation, negative 2 standard deviation. And, bottom 5% would be, wouldn't that be something like negative 1.65 or 1.67? So how do we find the z-score, right? And and the idea is, since we know 10% is the expected return from our scenario analysis, and so from that 10%, if we multiply the bottom 5% z-score to our standard deviation, right? Which would be a negative number, and it will be a negative 1.6665. That would give us the return, right? That would be loss, actually, return that you get in the worst case scenario. But actually, because this is actually in return, the whole thing is in return, right? In other words, the whole thing is in percentage, right? If you multiply the whole thing by the fund, right? Size of the fund under our management, that will give you dollar value, right? Loss. Okay, so that's the idea. So let's do that. Let me stop this and share once again the Excel file, and you should see it just about now. Come on. Yeah. I can see it now. So then, how do we find the z-score? In the old days, there was a table, and you don't have to use table anymore. I mean, you have to and just like follow the column and follow the row, and you find like interest factor table that we don't use anymore. So to find that, all we need to do is Excel's norm norm inverse function, right? Norm inverse does what? What does it do? It will find the z-score for that probability, the percentile probability first, and then for the mean of the distribution of our sample, right, data, and our standard deviation. And I'm gonna lock these things because I'm gonna later drag it down. I don't have to actually because I'm gonna I'm gonna drag it down. So there you go. This is the z-score. First, this is the loss, the return at that bottom 5% probability. Z-score is actually found by norm standard deviation inverse. Okay, norm standard deviation, norm standard distribution inverse, right? And you just put the probability and hit enter. That gives us our z-score, which is negative 1.645. I mean, if you increase, let's increase decimal a little, right? Negative 1.6449. Okay. This is just extra. It's called cumulative distribution function, cumulative distribution under the z-score, right? And then, which is normal standard distribution and the z-score, which is give it the z-score, which is in E2. I'll have to type it in because the formula is all above it. It's across the two columns, and then either enter 1 or true. And then it will give you a probability, cumulative probability. Remember, this probability is cumulative probability, right? In other words, 5% all the way. I mean, the left tail end is open-ended, right? I don't know if you have that. I don't have time to switch back to PowerPoint, but remember, in the normal distribution function, right? The tail ends are actually, open-ended, isn't it right? The tail area is open-ended. In other words, they don't stop anywhere. They don't stop somewhere. When it's going on, it's open-ended, right? So, and we know that one standard deviation, right, around the mean, right? One standard deviation this way, one standard deviation this way, and so it's two standard deviations. Another, second standard, right? Another standard. Now, so this point is two standard deviations, right? This point is two standard deviation, but bottom 5% and below this two standard deviation, the probabilities falling in this extreme low tail, right? It's, open, it's 2%. But if it is like from here to here, right? From, you know, this this vast openness, right? But it's only 5%. All the probabilities of falling, into this vastness is, cumulatively 5%, right? And falling below here is cumulatively 2%. That's what it means, right? This percentile, right, simply means, basically cumulative, probabilities. So what this is giving you is it's inverse, right? The cumulative probability of the area below this z-score is 5%. That's what it means, right? So once we have, and then you see that there are two more columns, but I collapsed them because we don't need them at this point. But once we have done that, let's try this. So if the 5% percentile, 10% percentile, right? What would be the z-scores, equivalent z-scores, and what would be the matching z-scores, and what would be the returns, for those, right? And think about it. 50% means, this point, right? %50 means, this half point, right? Right? 50% means all the probabilities, up to this point is 50%. Isn't that right? And then there's another 50% there, right? So let's see what would be the the returns, up to that point, and we can already tell, because if the cumulative probability is this 50%, then we are here, which is our mean, isn't it right? Which is our mean. So at that point, then our return should be 10%. Makes sense? We can already take a guess, and that guess is quite educated, logical guess, right? But let's see if it is true, right? Let's see if it is true. So since I locked it, right? Remember, since we locked it, right? All we need to do is let's highlight this too and just drag it down. Drag it down. And let's see what all of these will tell us. Oh, no. All these, I'm sorry. All these. All those things were also. Okay. Just. Oh. Okay, let me drag it down all together, and I'll erase that. Where's the eraser? Okay. So, what did I say? Something stuck. Oh, what did I say? If the cumulative probability is 50%, it's going to be right here. So we should have exactly 10% for our return, right? And at that point, our z-score should be 0, right? Because if z-score here is negative 2, I mean, if it is standard normal distribution, right? But our distribution is not standard normal distribution. It is normal distribution, but not standard. What is standard? What's the difference? Standard normal distribution is the normal distribution with mean of 1, right? And the standard deviation, a mean of 0, and standard deviation of 1. So it's like a standardized, right? But our distribution has mean of 10% and standard deviation of 18%, right? Makes sense? So the z-score, so in other words, z-score is the normal standard normal distribution, right? These notches. If we put if we make notches on like this is 0, negative 0.1, 0.2, negative 0.2, 0.3, 0.4, 0.5, 0.6. I mean, if you are making these small incremental notches on the horizontal axis, then that's z-score. So by standard normal distribution, right? At 50% point, cumulative probability of 50%, it should be 0, right? Right? And then that's the cumulative distribution, right? And then in our distribution, right, it should be at mean of 10%. Make sense? Also try, and you can tell that all the z-scores beyond this point is positive. It's 1, 2, right? 0.1, 0.2, 0.3, right? If we are looking for something like 5 percentile, right here, if you are looking for z-score, okay. This is the z-score of top 5% or 95 percentile, right? 95 percentile. Right? If you want to find z-score of 95% percentile or top 5%, we already know the answer. It will be exactly 1.6449, right? Positive, right? Because it's the mirror image. It's a mirror image of the left left tail, the left-hand side. So let's see what would be the dollar result, right? Again, for if our fund is $1 million, right? Our fund, under our management is $1 million. So value at risk, right? At lowest in dollars, how much would that be? In dollars, how much would it be? It's basically, this basically, mean, right, times z-score, right, times, this is plus, I'm sorry, mean plus z-score times our standard deviation. Should be. And then that would give us actually this, right? Negative, we already know the answer, right? That will give us this. And then times, the negative 20.64% of our $1 million would be what? Negative 206,443, right? And then I have, because that is exactly, this thing, right? And then I already did it by, if you multiply this by this, right? Or multiply that by this, it's the same thing, right? Okay, maybe I may not need this, so I'm gonna delete that, and then it's gonna it's gonna go crazy, and then okay. So this way, again, you can also drag it down and find. I mean, if you are the 10th percentile case, right? 15th percentile case, right? I've done it by 5% increment, but 50 percentile case scenario, you will get exactly $1 million. I mean, I'm sorry, 100,000 will be the return. Now think about it. Out of 1 million, right? You hit exactly expected return of 10%, so your return should be exactly 100,000, right? Make sense? Yeah. I'm gonna have to clean this up later. But as the columns expanded, right? Another thing is, this would be a case of normal distribution, right? I mean, if our scenario analysis, if our scenario was perfectly normally distributed, right? In the worst case scenario, right? with this mean and this standard deviation, our loss would be negative 20% and negative 37%. You remember our was table severe recession. Under severe recession scenario, the return would be our scenario analysis is assuming that in the worst case scenario, right, a bottom 5% scenario, right, the return would be negative 37. So this is, but normal distribution would tell you if it is normally, all the returns are normally distributed. The worst 5% case scenario, in the worst 5% case scenario, our return would be negative 20. So what can you tell? Our scenario is exaggerated. I mean, it's underrated, or negatively over exaggerated, right? Our scenario is more pessimistic than what is statistically predicted, right? Okay, so that's what our value at risk can tell us. I mean, it's not just value at risk. Value at risk is the worst case scenario, but if we follow the normal distribution, we can tell our worst case, our scenario is not just slightly, it is kind of grossly exaggerated, pessimistically exaggerated, right? Mostly pessimistic. Alrighty, so that's it for now. I'm gonna have to stop recording. Spend more than like 38 minutes. So I will see you guys in the next video. Stop recording.